Today, we'll be doing a lesson on kinematics, so basic physics kinematic problems. We start off with our four kinematic equations, which we can see right here, and with this problem. B29 is flying at a constant velocity of 150 meters per second, 1,000 meters above the Earth. To test and calibrate the new bomb sight, the payload is released. A, calculate the distance between the bomber and the payload in the x direction at the moment that the payload strikes the ground. For this, we can simply just start by drawing an image of the aircraft. We know that the velocity in the x direction is going to be 150 meters per second. This also means that the second the payload is dropped, its x velocity still has 150 meters per second value, but its y velocity initially is 0 meters per second. Now look at these two numbers, they're the exact same. And this means that at the time that this payload strikes the Earth, the aircraft will be at the exact same position right above it along the x-axis, meaning here is a trajectory, here's our imaginary x-axis. By the time the payload strikes right here, the aircraft will already be here, because they're both going 150 meters per second in the x direction. Henceforth, A will be 0 meter. Now for part B, we need to calculate the time that it takes to strike the ground. So for this, we just use our fourth kinematic equation. The reason is because v y 0, so v initial of y is equal to 0 meter per second. And this means that when we use a fourth equation, this v0 times t will just cancel out to be 0. So now we could write the equation. Negative 1,000, because remember the payload is going downwards 1,000 meters, equals 0 minus 1/2 of 9.81, which is equal to 4.905. And again, this value of acceleration is negative, because remember that acceleration is going downwards. So that means it must be negative. And then time squared. So now we can just use our calculator to calculate for time. 1,000 divided by 4.905. We take the square root of that. We get t equals 14.3 seconds. Yeah. And your answer might differ very slightly depending on whether you use 10 meters per second squared or 9.8 or 9.81 for acceleration. But yeah, here's our answer for part B. 14.3 seconds. For part C, we just need to find the total velocity. Now this implies that we also need to find the magnitude and the direction. We already know the x component. The x component is simply going to be 150 meters per second. To find the final y component of the object's payload, Vy, we could just resort to using the second kinematic equation, for which we get Vf equals V initial, which remember is 0 initially, minus 9.81 t. And we know that t is 14.3. So now we get that V final equals negative 140 140 meter per second. So now we can just use Pythagoras theorem equals square root, v equals square root of 140 negative 140 squared. So now this is positive plus 150 squared. And we get an answer of around 205. 0.23. Now again, your answer may differ depending on how you rounded it or what value of gravity you use, but you should get around 106, 105, possibly 104. And now for the angle, we already know that it's going to be below the horizontal. But to find it, we just do tan inverse tangent and the angle we're trying to find is essentially going to be like this. I'll draw it right here. This angle right here, theta. Here's our y component and x component. So that means this is going to be the perpendicular and this is going to be the base. And tan is perpendicular over base, hence we're going to do y over x. So it'll be inverse tangent of 140 over 150. And I'm using a positive value for 140 just so I can get this exact value of theta with no weird negative numbers with the unit circle and things like that. Because I already know I can change it based on it being above or below the horizontal. Yeah, so we just do inverse tangent. And we get approximately 43 degrees. So those are our answers for part C. Okay, now we can move on to our next problem. A king tiger tank positioned in a line of foliage surveys a beautiful French countryside. Upon seeing a lone Sherman Firefly, the king tiger's gunner uses the rangefinder and determines the distance to the enemy. He then elevates the gun to 10 degrees and fires a shell. 2 seconds later, after the powerful 105mm cannon has fired, the Sherman Firefly erupts in flame as its ammunition cooks off. The shell has a velocity of 1,150 meters per second. A. How far away was the Sherman? And B. What was the maximum height reached by the shell? So let's write down what we know. We know that the gun is elevated at 10 degrees. And that the velocity is 1,150 meters per second. Now, we also know that after 2 seconds, the shell went and hit the enemy tank. So here we need to basically use distance equals velocity times time to find the distance away. But we need to find the x component of the velocity. And to do this, we could just use cos theta times v. So that's going to be vx equals 150 times cos 10 degrees. And this gives us a Vx of 1132 2.53 meter per second. So now we can just find the distance. By distance equals 2.53 times 2, because 2 was the time it took. 2 seconds was the time the shell took to land. So we multiply this by 2, and now we get 2 equal sign 2265.06, which is approximately 2.265 kilometers km. Font kind of got messed up. So I guess this is our solution to A. 265 km. Now for B, we know the shell trajectory is as such. And right here is T equals 2 seconds. We need to find what was the maximum height. The apex of this trajectory will be reached exactly in the middle of this distance, which means it will be achieved exactly when T equals 1. And now we can essentially use kinematic equations again. We could use D equals V0T 1/2 AT squared. Because we already know what T is. We don't know what distance is, but we can calculate the initial velocity. And this initial velocity will be essentially the y component of this velocity. And since this is going to be 10 degrees, Vy equals 1/150 sine theta, which is 10. Hence the upward velocity initially of the tank shell equals 199.7 meter per second. Now we could use distance formula. Distance equals 199.7 times t, which means it'll just be the same as 1, minus 1/2 acceleration. Now acceleration again, negative 9.81, and 1/2 of that is negative 4.905. 4.905 times t squared, which is again is 1. So now we have 199.7 minus 4.905, which yields us maximum height. So H max, let's fix the H max equals 194.8 meters. Now we can move to the final problem. Om Ramchandraji is taking a peaceful stroll looking for fossils at the base of the chalk cliffs of Sussex. His chicaneous brothers want to annoy him by throwing rocks at him. Positioning themselves at the top of a 110-meter high cliff, they ambush Om Ramchandraji, who is directly below, by throwing a chunk of fossiliferous limestone straight up with a velocity of 2 meters per second because they are so weak. A. How long does Om Ramchandraji have to dodge the rock? And B. What will the velocity of the rock be when it hits Om Ramchandraji's head if he is 1.8 meters tall? Let us start with part A. Essentially, let's draw a diagram. We have the height, it's 110 meters. But we also have Ohm-Rom tundra G's height, which is 1.8 meters. And now we have the initial velocity, which is always in the y direction. It's only in the y direction, because I threw it with 2 meters per second straight up. So 2 meters per second. And we have our gravity going down, 9.81 meter per second squared. So we need to see how long does Ohm-Rom tundra G have to dodge the rock. Now we could use the third equation for this because we already have distance and we have initial velocity and we need to find time. So we could use d equals v0t plus 1/2 at squared. And distance here is not going to be 110 or negative 110. The reason why is because Ohm-Rom tundra G is 1.8 meters tall. And this means that the actual height or the actual distance that the rock travels is 110 minus 1.6. That is 108.4. 108.4 meters. Hence we have negative 108.4 equals 2t minus 4.905 t squared. Now we essentially just have a quadratic equation we could solve. And once we solve this quadratic, should be 2 plus or minus square root of 2 squared minus 4 times 4.905 times negative 108.4 over 9.81 because that's 2 times the a value, which is 4.905. Yep, and we get t equals, and we had to add, by the way, because once you do this huge expression inside the radical, it's much greater than 2, which means subtracting it would yield a negative time. So we just use addition here. And we get t equals 4.856 seconds. So that is our answer for A. Now for B, what will the velocity be when it hits Ohm-Rom tundra G's head? For this, we can simply just use V equals V0 plus AT. Because we already have the time, and we already know the initial velocity. V equals 2 minus 9.81 times 4.856. V equals okay, yeah. And of course your answers may differ. It's like slightly like around 45 to 46, possibly a little bit more, a little bit less. But you should get around this number if you use anywhere like 9.81 or 9.8 or 10. And remember, it will be negative because it's going in the downward direction. So, if you enjoyed this video and happen to be in a tank in the French countryside and spot the like button, Please use your rangefinder, kinematics knowledge, Panzergranate 40 shell, absolutely smash it into oblivion.